using the DTX cable analyzer and the optional fiber modules in the back. You'll notice on the table here I have my inspection and cleaning equipment. I've already inspected and cleaned my test reference cords. Without the inspection equipment, it's going to get very unpredictable. You'll notice I use the term test reference cord and not patch cord. That's because I'm talking about cords which have reference grade connectors on them. According to ISO IEC 14763-3, for multi-mode these need to be better than 0.1 dB and for single mode better than 0.2 dB. Now even if you're testing to the TIA standard, you should aim for 0.1 and 0.2 dB because that's going to get you consistent, reliable test results. So first thing I'm going to do is connect it to my main unit, and here you'll see this red device. This is a mandrel. You need to be using mandrels. If you don't, your results are going to be pessimistic. So the mandrel end is connected to the output port on the main unit, and then we're going to connect directly into the remote unit. We are not going to set a reference through a bulkhead adapter. I have a 50-50 chance of getting this right. These are fluke TRCs. So red is hot, which is the output, black is cold, which is the input. So I'm going to take my black and connect it to the input on the remote unit here. Then I'm going to take my other test reference cord and do exactly the same, but from the other end. So with the mandrel, red is hot, so that goes to the output port. And then the other end of my test reference cord, again 50-50 chance, but since these are fluke TRCs, we know that red goes to black, hot to cold. So and that chirp indicates that I got the polarity correct. So let's talk about setting up your DTX cable analyzer. So we're going to rotate the dial to setup, and with fiber loss highlighted, we're going to hit the enter key. My test limit is currently selected to TIA, and that's what I'm going to be using today. But if I was to test to the ISO IEC 14763-3 standard, I would hit the enter key, F1 more, and go and select the ISO folder, where I'll find my standard. My next setting in here is my fiber type. It's currently set to OM2, and as you can tell by the cables, I'm testing OM3 fiber today. So I need to change that to OM3. That's going to impact what shows up at the bottom of my Linkware test report. At the bottom of the Linkware test report, you're going to see a list of supported applications for the fiber you just tested. If I'd left that at OM2 fiber and the link was greater than 82 meters, then 10G base SR would not show up at the bottom of the test report. But by selecting OM3 fiber, as long as that link is no greater than 2.6 dB in loss and is 300 meters or less in length, then I will see 10G base SR show up at the bottom of the test report. My other options here are remote end setup. It's set to smart remote because I'm doing duplex testing, and bidirectional testing. This is not a requirement in TIA or ISO. However, your consultant or end user may specify this, so please check with whoever wrote the test specification. Let's go across to tab number 2, where we see the number of adapters. This is going to impact your test limit, so this is important to get this correct. This is the number of bulkhead adapters added after you set the reference per fiber path. Sounds complicated? Not really. We are setting a reference, but we're not setting it through a bulkhead adapter. And the link we're testing has a bulkhead adapter at one end and a bulkhead adapter at the other end. So our adapter count's going to be 2. The number of splices is set at 0, even if I'm using mechanical connectors such as unicamps. They have a mechanical splice built into the connector, but that's part of your allowable loss. The only time you would enter a splice in here is if you're doing fusion splicing with pigtails, or indeed there is a splice in the middle of your link. The connector type is set to SC, since that's what we're testing today, and that's not going to affect the outcome of the test result, but it will affect the help screens that are going to appear on your DTX. And then finally our test method, one jumper, because we're jumping from the main to the remote in one go. We're not going through a bulkhead adapter. We're going to do one jumper per the TIA and ISO IEC standards. And then finally, tab number 3, we have the index of refraction. That's going to affect the length reported by the DTX cable analyzer. I recommend that you go to the cabling vendor's website and get the latest data sheet for that fiber and make sure the values match up. If they don't, this is the menu where you would change those values. Okay, so we're ready to set a reference. My sources have been switched on and been allowed to stabilize for at least 5 minutes. It may take longer if these were stored in a colder condition. So with set reference highlighted, I hit the enter key. It draws a picture of my setup and then I hit test. And now what it's going to do is it's going to reference out the connection to the output ports and the fiber between the two testers. And it's going to come back with some power loss values. They're power loss because they're in dBm, dB milliwatt. Now as a guide, if it's 50 micron, you want these to be better than minus 24.5 dBm, where minus 22.5 dBm is better. If you're doing 62.5 micron, you want it better than minus 20 dBm, and if you're doing single mode, you want it better than minus 8 dBm. And if you're doing single mode, make sure that your cords are laid out straight, otherwise you're not going to hit the desired values and potentially end up with negative loss readings. So I'm good with these values here. I'm going to press F2. I can put in the length of the cords that I'm using here. Again, it's not going to impact the outcome of the test result, but it will show up on your test report. F2 OK. Now, what I want to do is I want to make sure my sources are stabilized. So I'm going to rotate the dial to auto test and run a test. And if the sources are stabilized, then I should see 0 dB loss for each fiber path. The input fiber is the input fiber on the main unit, and that is showing a loss of 0 and 0 dB. I'm ignoring the paths and the limits and the margins. I just want to look at the loss values and make sure they're 0. They are. So that tells me my source on my remote unit is stabilized. On the output fiber, again on the main unit, we're seeing 0 and 0 dB loss. That means that my source is now stabilized on my main unit. So the next step in the process, what we're going to do is disconnect the fibers from the input ports. So I'm going to disconnect it from the input port on the main unit and put my protective cap on there. I'm also going to disconnect it from the input port on the remote unit. And again, carefully put my cap on there to protect the end fiber. Then on the main unit, where the mandrel is, adjacent to that, you will find your SC connector here, which is also black, which goes to the input port because that's cold. And we'll do the same on the remote as well. So from the remote unit, I now have duplex cords, and on my main unit here, I also have duplex cords. So I could just go off and plug this into my patch panel at one end, and these to my patch panel at the other end. The problem is I don't actually know how good these cords are. So what I want to do is I want to check out to make sure these are good. So even though I'm doing multi-mode, I'm going to use a single mode rated bulkhead adapter, and I'm going to connect the main and the remote units together. Remembering black to red, red to black. If I get this right again, we'll hear a chirp. Okay, so what I'm going to do now is I'm going to run a test to see what the loss is in this connection here, and hopefully it's better than 0.1 dB because that's what we want for multi-mode. If it was single mode, we want better than 0.2 dB. Again, if single mode, make sure the cords are laid out straight. And again, I'm hoping for 0.1 dB or better. And our input fiber, which is our input fiber to the main unit, is 0.01 and 0.01, which means this is a near perfect test reference chord on that fiber path. Not forgetting to go and check our other fiber, 0.09 and 0.08. Excellent, exactly where we want to be. So I know that my test reference chords are in good condition. Now, there is a good idea here to tell the technician to save these two test results as TRC1 and TRC2 or something similar and include them as part of your test results package. That way, everybody knows that the test reference chords were in good condition when the testing was conducted. Okay, on to the final step. We know our test reference chords are good, so disconnect it from the bulkhead adapter in the middle. And very important to protect our fibers. So I'm going to cap them, especially if I'm on a building site. Do the same for the remote as well. And then this end will be taken to one patch panel and this to the other end of the patch panel, and then you'd run a test. And that is how you would successfully test an SC to SC duplex fiber link using the DTX cable analyzer and the one jumper reference method.